If the current direction is reverse, it will not going to be operated. But in directional circuit breakers, when the current direction is reverse, immediately the relay is going to trip the circuit breaker. సో ఇక్కడ మనము ఈ స్కీమ్లో మీరు గుర్తుంచుకోవాల్సింది ఏంటంటే డైరెక్షనల్ రిలేస్ ఎక్కడ కనెక్ట్ చేస్తారు, నాన్ డైరెక్షనల్ రిలేస్ ఎక్కడ కనెక్ట్ చేస్తారు. ఇది చాలా కాంపిటేటివ్ ఎగ్జామ్స్లో వచ్చింది. సో ద డైరెక్షనల్ రిలేస్ ఆర్ కనెక్టెడ్ నియర్ టు ద లోడ్ సైడ్ and the non-directional relays are always equipped at the source side, right? So here out of this AB and PQ, AB are the non-directional relays, whereas PQ are the directional relays, right? Suppose without any fault in the system, the current will travel from this substation to this substation, either of these feeders, in this direction, right? So without any fault, the direction of the current is from sending end to receiving end substation from both the feeders. The advantage of this parallel feeder is, what is the advantage of parallel feeder? When one feeder fails to operate, we can still run the system with another feeder. But in the radial feeder, only single line is going to be there. When there is a fault in that single line, the load will not get any supply from the source. So that is the disadvantage of radial feeders. And coming to the parallel feeders, when there is a disconnection of any one feeder, we can still run the system from the another feeder, right? So that is a disadvantage. And also in the parallel feeder, we have advantages like the net reactance is going to be reduced and the power handling capacity is going to be increased. So these terms you need to remember, as it is a bits type examination. For every point should be very clear for you, then only you are going to answer the questions. Now suppose if the fault is occurred here in the middle of A and P circuit breaker, somewhere near in between of A and P, what happens? The current, whatever it is traveling from, whatever the current it is traveling from A circuit breaker is going to be go to the fault side. Okay, so it is going to be go to the fault side. So there is no current to the P side, P circuit breaker, right? Similarly, whatever the current is carrying from B and Q, because of fault means it is very less resistance, this current is also going to be choose this path. So this is I, suppose it is called IB, and this is IA. Now what is the total fault current? IA plus IB. So this is the disadvantage of parallel feeders. Suppose if the fault is occurred, the fault current magnitude will be increased very huge. Okay, so what happens? So as this current is traveling in this direction, this P circuit breaker whatever is there is a directional relay equipped with directional relay. So when the current direction is in this direction, the relay is going to be operated. So now here the current direction is reverse, right? Previously in the normal case the direction of the current is this one, now it is this one. So what happens? The relay gets energized and it is going to be operated, and which open the circuit breaker. So once this circuit breaker is operated, what happens? The line will be disconnected. Again when it is healthy, again it is connected to the system, right? Similarly you can analyze with this side also. If the fault is occurs here, whatever the current is there from B, it is going to be in the fault side, and whatever the current is there, we'll choose this path because this side the impedance is very high and it is 0. So always the current choose the less impedance path. So the overall fault current is IA plus IB. So in that case, what you are going to do is you are going to operate the directional relay. So when directional relay detect the reverse current, means change of the current, then immediately the relay is going to be operated. In this case, actual current is this one. When the fault is occurred, the current is shifted to in this direction. So immediately the relay gets energized and will going to be operated, which disconnects the feeder. Okay. But when you disconnect this feeder, still there is a power to this feeder from this. Okay, when fault is occur here. So now if the fault is here, so it is isolated. Still the power is flowing from this side. Okay, so that is the when the power that is the advantage of the parallel feeder, right? So the explanation is given clearly here. You can understand that explanation. And third one, ringmain system. So ringmain system means the feeders are connected in such a way that feeders and sources to form a ring. Suppose here this is the source. These are the different substations going for different areas. Normally, the now substations are using most of the cases this one only. They use combination of radial feeder, parallel feeder, and ringmain. But every overall system is always ringmain because to divert the power from they based on the load, they always use ringmain. So ringmain system, this one is a ringmain system where all the substations and source and feeders are connected to form a ring. Okay. So under healthy, if you see the rating, each circuit breaker is using a now definite time relay. Okay, each circuit breaker is using now definite time relay. If you see that each feeder, we are having one non-directional, one directional. When there is unidirection arrow, that means it is directional. When it is bidirectional arrow, that is non-directional, right? So here every feeder has two types of circuit breaker. One is equipped with directional relay and one is equipped with the non-directional relay. And out of this directional and non-directional, and they are definite time relays, and they are rated such a way that in the clockwise it is 2.5, 2, 1.5, 1, and zero point 0.5. Right? Okay. But in the anti-clockwise it is 2.5, 2, right? 1.5, 1, and zero point 0.5 seconds. So this type of time grading we are using to make sure of if any fault occur anywhere, the nearest circuit breaker to be operated within that time. So under healthy system, all substations will get the power from the source. Suppose if the fault occurs here, what happens? This line will be disconnected by either E or F. Mostly in case of E will be open because it is directional relay. As the current direction is reversed, this relay is going to be operated as in the similar previous case. But here, even though this line is disconnected from the system, still this substation 3 will get the power from this direction. Okay. So from both sides, it will get the power. So when one side relay or feeder gets opened, the substation will get still the supply from the another side. So there is the advantage of ring main system. You cannot have a situation like any substation will not get the power from any side until the both sides feeders are failed. That is very rare case. Okay. So that is ring main system. You can go through that one. And the next one, that is time graded overcurrent protection scheme. Time graded overcurrent protection schemes low. You have how many types? First, there are three feeders: radial, parallel, ring main. Each feeder in the radial feeder we have two schemes: uh, constant, definite time, and inverse time. And next, parallel feeder we are using directional and non-directional relays. Right? In the ring main we are using directional and non-directional relays to protect the equipment from both sides. Right? So you have to go practice all the diagrams and see the principle of operation, how they are working when a fault occurs. Okay. So the next type of scheme is differential protection scheme. So in this differential protection scheme, it is mostly used in case of generator, transformer, feeder, and bus bar also. Differential scheme is very important. That's why in the second chapter, I have explained clearly differential protection and its disadvantages very clearly. Advantages, disadvantages, and challenges. Five challenges are there. CT mismatch in CT ratio, and that is also you have to be very clear. Mismatch in percentage errors, ratio errors. Okay. So the saturation of CTs. There are five reasons. How to overcome those five? Also, you have to know to mark the uh, bits. Okay. Now, so coming to this one, suppose if you take this as a feeder, okay, from the starting you have one circuit breaker, from the ending you are having another circuit breaker, right? So to detect the current, we have placed two CTs, okay, in opposite polarity manner. They are connected, and there are two relays, right? So the another side of the CTs are connected with two wires, right? Two wires with equal distance of what? Feeder. ఇక్కడ నీకు డిసడ్వాంటేజ్ ఏంటంటే ఇలాంటి స్కీమ్లో సపోజ్ 100 కిలోమీటర్స్ లైన్ ఉంది అనుకోండి, యూ రిక్వైర్డ్ 100 కిలోమీటర్స్ లైన్ పైలట్ వైర్స్, వి కాల్ ఇట్ యాజ్ ఎ పైలట్ వైర్స్. దీస్ ఆర్ పైలట్ వైర్స్